Welcome back, Warhawks. Today we are going to be discussing Chapter 3-2, which is dealing with area of triangles. In the last section, we dealt with the area of squares, rectangles, those four-sided figures with right angles. Today we're going to be doing that with triangles. So our goals are to determine the base and height of a triangle. Just like in a rectangle or square, we need to have a base and a height. And we're going to be able to use the formula for area of a triangle to find these areas of the triangles in the coordinate plane. So let's just get started. The first thing we talked about in class, how you need a base and a height if you're going to find area for a lot of shapes. Or if they ask you, hey, what's the height of this shape? The thing that you need to look for is always going to be the 90-degree angle. That's where you really want to look to see where the base and the height of two shapes come together. So any time that you're asked for a height, you think about how you measure yourself. You measure your height from the top of your head down to the ground in a 90-degree angle. So the same thing for triangles. We're going to be measuring the height of these triangles using these 90-degree angles. So here we have a right triangle. So we already have a right angle. I would call this right here my base, and I would call this right here my height. Where the base and the height come together is a 90-degree angle. Just so happens in this picture, our base and our height happen to be sides of this triangle. However, in this triangle over here, we have a base and a height, and the height's actually not a side of the triangle. So I just had to, from an angle, draw an altitude to the opposite side to create that height of that triangle. So here's our big triangle. The height wasn't in there, so I actually had to draw it. So I had to go ahead and draw in that height right there. So in this triangle, I would consider this side down here my base, and then this side that I had to draw in here, this line I had to draw in there would be considered my height. But again, there's a right angle. Let's look at some more examples here. So now we have it in the coordinate. So I'm going to need to be able to find the base and the height of a triangle in order to be able to find the area of a triangle, because the area of a triangle is going to be this formula over here, which is the base times the height, but this time we're actually dividing by 2. And the reason we do that is because all triangles are actually half of a corresponding rectangle with a base and a height that would be the same. So here in this triangle, we need to find the length of the base. So here's a base, and the reason I'm choosing this side is because I'm going to have a line that I can draw from this vertex to the opposite side, which is going to create a 90-degree angle. So we see here, if I drew in like a dotted line here that goes straight down, I would create a right angle with that base. So let's find the length of this base. This is an easy case because we can just count. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is the length of that base. And then the height here that I drew, which has to be a 90-degree angle, is 1, 2, 3, 4, 5, 6. So 10 is the base, 6 is the height. We plug it into the formula here. Base 6 times height 10, and then we're dividing that by 2. It's going to give us the area. 6 times 10 is 60, divided by 2 gives us the area is 30 units squared. It's going to be the area of that triangle. Let's look at another one. This time here I have a side and I see a right angle where these two sides come together. So that's where I want to look to find the base and the height. I would call this my base, I would call this my height, but again, I have to have a right angle there. So the base is going to be, I can just count, 1, 2, 3, 4, 5, 6, 7 is the base, and the height would be 1, 2, 3, 4, 5, 6, 7 as well. So now I plug this into my formula for area. Area is the base, which in this case is 7, times the height, which in this case is also 7, but we're dividing by 2. 7 times 7 is 49, divided by 2 is going to give us 24.5 square units, or we could say units squared. Now, I also talked about how, remember that a triangle is actually going to be half of a rectangle. If we kind of drew in this other part and we had a rectangle of height 7 and base 7, you can see it would be there. 7 times 7, the whole area would be 49. But then when you have a triangle, we're actually cutting that in half. That's where we get to divide by 2. Let's look at another example here. Okay, so I don't have a right angle in here, but I can see that if I start here, I can go straight down and draw in a line that's going to create a right angle. And the reason I'm doing that one is because it's right there on a Y line, so that I can be able to just count to find the distance. So now I have a right angle there. I have a base and a height, so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. 8 is the length of that base. And then I can count the height that I've drawn here because it's a right angle and it's on a Y line. It's not a diagonal. So I can go 1, 2, 3, 4, 5 is the actual height of that triangle. So again, area formula, we do base 8 times height 5. 8 times 5 is 40, divided by 2, the area is going to be 20 units squared. And let's look at one more here. Again, I don't see a right angle, so I can't use the sides. This looks like maybe it is, but I'd have to actually find the slope of both of those lines to be able to see if it was. But I notice here, if I draw a line from this vertex, I can go straight on that Y line to the opposite side. So I'm going to go ahead and do that there. I'm going to draw this line. I didn't do a very good job of it, but there it creates a right angle because it's right on that Y line. So now this is going to be my base, this is going to be my height, and I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 would be the base, and the height would be 1, 2, 3, 4, 5, 6. So for the area, go ahead and pause it and see if you can do this problem as well. So we can see here's the answer. I went ahead and multiplied 12 times 6, that's 72. I divided by 2 and I got 36 square units for this triangle. We're going to try one last triangle here. I just want you to be careful when the scale changes. So here again, we don't have any right angles, but I noticed that this vertex, I could draw a line straight down there from that vertex that's going to be on a Y line to create a right angle. So I've created the height of that triangle. Notice I couldn't really do that here because it's not on one of those X or Y lines, but this one happened to be directly on it. I can draw it to that opposite side. So for the base, it is 1, 2, 3, 4, 5, 6, but notice how the scale is not going to be by ones, it's by fives. So it goes from 10 to 40, so the base here is actually a length of 30 because it goes up by fives. The height was 1, 2, but again, we're going up by fives, so 5, 10 would actually be the height. So then I just go ahead and plug this into my formula, and after I plug it in, base 30 times height 10 is 300 divided by 2 is 150 square units. So just be careful when the units change. That's it, Warhawks. Hope you enjoyed it, and I'll see you in class.